Yes friends, as part of this session, let us discuss or understand about one more modifier with respect to the variables. What is that? What is that modifier means? It is volatile. Okay, what is that? It is volatile. Okay, it is a modifier which is applicable only to a variable. Okay, if you do declare a volatile modifier for a particular variable, what will be the behavior internally? What will get happen, or what will be doing, or what will be the task by JVM? Okay, what will be the task by JVM? We have to understand. Okay, now of course even I don't know the practical example to prove this particular modifier. Okay, even I didn't get update in it. If you do get update in it, please let me know. Okay, so but I will tell the behavior or internal implementation of this particular volatile modifier. Okay, if I do get update, definitely I'll update it. Okay, now observe here, what is this means? Observe friends. Okay, it is a modifier. Okay, it is a modifier applicable to, okay, applicable to variables. Okay, variables. At which scenario you have to apply this variable, this modifier to a variable? Simple thing, observe here. Once again we have to talk about multi-threading a little. Okay, not much knowledge is required to understand this one. A little knowledge is more than enough friends. Okay, more than enough. Observe here. Okay, observe here. Think that I'm having a variable int I is equals to triple line. Okay, and think that this is available as part of a class called A. Okay, now okay, let it be. Okay, let it be this one. Okay, now if I do run this particular piece of code, before that if I do compile at okay, after compilation, let me run this one at runtime, where I is going to get stored at memory. Observe. Okay, at memory. Getting? Now let it be our RAM. Within this RAM, JVM is going to get some part of the memory. That memory is called as what? JVM memory. Okay, let it be JVM memory. Here I variable is having the value as what? Triple nine. Okay, it is having value as what? Triple nine. Now think that we are having multiple threads which are accessing this particular variable value. Okay, each and every thread accessing that particular value at memory. Observe here. Think that how a particular thread can access that variable value. You have to create instance, all of those things. Okay, I didn't put that one. Okay, multi-threading concept. To understand this volatile modifier, we are not recommended to even go for that code and understand. Okay, I'm just giving the description here friends. Okay, so this is the scenario. Observe here. Now T1 is one thing I want to know, or I want to make aware of one thing to you guys. What is that? What is meant by access with respect to variables technically? It is what? Printing a variable. Okay, printing a variable value. Otherwise what is that? Performing some modifications. Okay, performing some modification to a variable referring value. Okay, modifications by using arithmetic operators. Okay, arithmetic operators. Okay, arithmetic operators. Okay, now think that this one. Okay, observe here the same thing. Let me put here. Okay, I is having the value as what? triple nine. Thread T1 coming and executing, thread T2 coming and executing, thread T3 and thread T4. Okay, observe here, observe here. Now thread 1 is coming and executing or accessing, okay, or it is accessing what? This high variable value. What is accessing? It can use that variable value to print. Other one is what? It can perform some modifications by using what? Any one of the arithmetic operator. Observe here. Now this T1 thread, okay, this T1 thread is performing some modifications at its execution time, changing the triple line value to 1000. Okay, incrementing, performing addition operation. It is performing I plus plus operation. Think that for example. Okay, now it is incrementing the value of I to 1000. Observe here, in execution time of T1, okay, and it has modified the value to 1000, and this value is also important to us. Observe, now T2 thread has come. Okay, T2 thread has come. It is expecting I value to be as what? Triple line only, but currently what is the value of I at memory? 1000. See here, which is not equal to the expected one. Data inconsistency. Here we are getting inconsistency nature. What is this? Inconsistency or data inconsistency. Simple thing. If the result is different from expected output, okay, observe here, our expected nature, okay, if the result is different from expected output, okay, expected output, then it is called as data inconsistency. Okay, inconsistency, and this is the general meaning for this one. Okay, and based on this one general thing, we can have different types of inconsistencies. It is based on the implementations and functionalities. Observe here, think that simple thing, you are having an EMP table, enum, okay, and what is that? Sal is there and name is there. Now you have entered the data as what? One sal is what? $1000. Okay, name is what? Something Smith. Okay, and now here you entered the E number as what? 2. Now you didn't mention the sal, it is what? The null value. And observe here, the name is what? Clark. Now if I do retrieve this data, how will it be? $1 Smith, 2 and some dummy value, null value, nothing will be printing there to you. Observe here, is this your expected output? No, there should be the salary for this Clark, which is what? Data inconsistency. My output which is entirely different from expectations. Observe, if the result is different from expected output, okay, then it is what? Data inconsistency. It will differ from functionality to functionality based upon the scenarios. Okay, you can use this. Okay, you can use this, friends. Okay, data inconsistency means this one only. Okay, now let us talk about this one. Okay, now observe here. Okay, it is expecting the value as what? 999. Data inconsistency, the result value is different from its expected value. This is the expected value by this T2 thread. Now T3 has come, okay, it is expecting the value even as what? 999, okay, expected value is what? 999. Here also 999, okay. Now do we have data inconsistency here? Yes, we are having data inconsistency with respect to the variable, okay, with respect to the variable. How to solve this one? Simple. Observe here, how to solve that one? Simple thing. If I do declare this particular variable, if I do declare this particular variable with a modifier called volatile, then internally JVM performs many things. What is that? Observe here. What is that? Observe here, friends. What is that means? Observe here. Now, for each and every thread, in the case of multi-threading scenario, observe here, okay, in the case of multi-threading scenario, okay, in the case of multi-threading scenario, okay, in the case of multi-threading scenario, okay, multi-threading scenario, this volatile modifier variable will be having a separate copy. This variable value will be maintained as a separate copy to each and every individual threads, okay. So JVM will maintain this one. So this is what dummy copy, okay, just a duplicate, okay. It will be as what? 999, and here also it will be as what? 999, okay. Here also it will be as what? 999. Here also it will be as what? 999, okay. I variable value, okay. Now it can change the value as what? 1000, no issues. Now at the time of execution period of T2 thread, its expected value is what? 999, no issues. It is having the value as what? 999. And at the time of execution of T3 thread, what its expected value of I999. So 999 is available to it, okay. And for T4 it is what? 999. No data inconsistency. We are having data consistency, okay. We are having what? Data consistency, through which modifier we are intimating to JVM like what? Hello JVM, at the time of or at the scenario of multi-threading, just maintain a dummy copy or local copy to each and every thread, and don't disturb the actual copy, master copy, okay. Master copy will be maintained at memory at some area, getting at some area, okay. This is the actual copy. These and all are what? Dummy things, okay. Dummy things, okay. These things will be maintained by our JVM, okay, to each and every thread who is maintaining these variables, that is creating this I variable as a dummy copy to T1 thread and to T2 thread, for T3 and T4 who is creating our JVM, okay. JVM creating all of these things. JVM has to execute our code. Internally it has to perform some other task, and once again you are making JVM to do all of these things. It is what? It is what? A burden on JVM. Is it correct or not? Yes, it is some burden on JVM. Getting? So observe here. Now is this an advantage to us to improve our performance? Is it advantage to us to improve our performance? Observe here, okay. Observe here. If you do observe this scenario, you can tell one thing: you are making some burden, you are just assigning some more burden to JVM. So here performance issues are getting raised. So you can tell that no advantages. We are having the disadvantage because of this modifier with respect to variables. What is that? Performance. Okay, performance degradants will be available. That is, performance will be low. Strictly what it is? Execution time will be much. Okay, execution time will be much. Once you execute the code, it should take it should take lesser time to execute and to give the output. Okay, then it is called very good application performance. Okay, so observe here what we have discussed here as part of this one. Okay, let it be before we go and brush all of those things, one other important thing is what, let me talk about for a while final modifier with respect to the variables. If I do declare a variable as final int I equals to 9. Okay, now within the constructor, can I assign its value or can I change its value like this? Can I do like this? Yes, can I do or not? Yes, you can do, but it will be giving compile time error to us. As what? Once a value is assigned to final variable I, you cannot modify its value. This is what, guys? Reinitialization, right? Reinitialization, that is modifying the value. First time initialization, okay, first time assigning a value, okay, later once again you are performing modification, so if it is so, it will give compile time error to us as what, friends? Cannot assign value to the final variable I. Okay, so final means what? Constant. In entire life of your program, this final variable value must be 9 only. It should not get changed at any of the instructions. Okay, now observe here, what is this volatile? Here its value can get changed in the local copies or in the dummy copies. In the dummy copies, it can get changed any number of times, no issues. But the actual copy, the master copy, okay, the master copy is safe. So it is always illegal combination of modifiers. What are those? It is always illegal combination of modifiers, final and the other one is what? Volatile. Final and volatile forms illegal combination. Okay, illegal combination. Final, volatile, int I equals to minus. If you do declare, it will give compile time error as what? Illegal combination of modifiers. What are those? Volatile. Other one is what? Final. Okay, illegal combination of modifiers, final and volatile. Okay, so when and at which scenario we have to discuss about, or we have to introduce, or we have to declare a variable as volatile? When means when at the time of multi-threading scenario, if there is any data inconsistency, okay, if there is any data inconsistency, then we have to go for that modifier. Let me brush it once. Okay, so first what we have discussed, volatile is a modifier which is applicable to what? A variable. At which scenario JVM will have its own implementation, otherwise what will be the internal implementation for this volatile variables? Okay, what will be the internal implementations by the JVM? Getting, if we do declare a variable as volatile, internally JVM performs some implementation. What is that? We are going to see once again. Okay, let me brush it once. Okay, so at multi-threading scenario, okay, at multi-threading scenario, if T1 is executing or accessing a variable value, and if it is modifying the value as what? 1000, let it be modifying that one, or it can decrement also, no issues. Okay, in between this execution, T2 thread has come here. It is expecting I value to be as what? 999. But what is the value of I at memory? It will be as what? 1000, right? 1000, getting, because of I plus plus, getting, but here it is expecting the value to be 999. So what is going to raise here? Data inconsistency. If the result is different from expected output, then it is called as what? Data inconsistency. Okay, now how to avoid this data inconsistency with respect to the variable? Observe here. Okay, observe here. Okay, what is that? If I do declare a variable as volatile, what happens? Internally JVM maintains a local copy or a dummy copy to each and every thread. Okay, who is going to maintain these things? Our JVM. Okay, so because of this maintenance, okay, we are having, we are assigning some extra task or burden to the JVM. Internally JVM is having many algorithms to run and execute, getting, so it is one more extra task to the JVM, which always degrades or makes our application performance to get slow, or it makes our application performance degradance. Execution time is very high. Okay, observe, this is what our volatile thing. And with respect to the final modifier, final means what? That variable, that is, if a variable is declared as final, means its value should not get changed at any time in the entire life of the code. If you do modify, it will give compile time error to us, getting. Now with respect to this volatile, you can change that volatile variable. Okay, you can change this volatile variable value within the code in its entire life, that is, in the entire life of application you can change it. Okay, but modifications where it is performing within the dummy copy or local copy, but not at the master copy, so its value changing. Okay, so final means what? No changing, but volatile means what? Can change. Okay, so it is forming a legal combination of modifier with respect to the or with volatile, volatile is forming a legal combination with a final modifier. Okay, this is what we have discussed. And so the performance here is going to get degrade. Okay, that is, disadvantage is what? We are assigning some extra task to the JVM to maintain this local or dummy copies, so performance will be getting down. Okay, that is what the disadvantage. Advantage is what? Of course we are not having any advantage. If you are so smart, you can tell one advantage. What is that? What is that? Observe in this area what you can achieve. Simple thing. What is that? You can achieve data consistency. Getting, data consistency. Getting, you are making data inconsistency to the data consistency. Getting? That will be the advantage, okay, if you do use this modifier. Okay, this is what our volatile modifier with respect to the variables. Now let me brush each and every modifier till now whatever we have discussed. How many modifiers we have discussed? How many modifiers, friends? All together 12. Getting? All together 12 we have discussed with respect to each and every property of a class. Okay, with respect to each and every property of a class. Simple thing, observe here how to remember that one. Okay,